We put all the data on real time out to the web, and it's there in databases for everybody to go and get and use. And that's a very typical thing in Aurora science. So I think that international collaboration we have are really moving us forward, because many things are so complex that if you have just one scientist or a very small group of people with the same mindset, it's very hard to reach very far. You really need many people with many different backgrounds.
Although the Aurora is nearer to giving up its last few secrets, for now it defies complete comprehension, tempting scientists to try and unravel the mystery, no matter the risks. When Paul Kintner's rocket launched into the Aurora, he expected to gather enough precious data to keep him busy for years.
I stepped outside to watch the rocket go, and then I didn't see the third stage ignite, which confused me. And that's when I realized that things were not quite okay.
It turned out the rocket had crashed, some 20 kilometers away. This footage of the recovery of the experimental equipment was shot by Kintner's team the next day.
We don't know the cause of the failure, but we know what failed. And that is the third stage of the rocket. It failed to ignite. And as it happened, it landed about 60 to 80 meters off a snowmobile trail. So they were able to pick up the payload. It was in 3 pieces at that point, pick up the payload and some of the smaller parts. So they brought it back, and that evening we got a chance to start inspecting what had happened and understand the full gravity of the situation. Sit, good, stay.
Back home at Cornell University, Paul Kintner puts his winter gear into storage until the next rocket campaign. His first task is to examine the debris with his engineer, Steve Powell, to see what might be salvaged.
So I don't think that did any damage.
These are out of the rocket, aren't they?
Yeah, this is from that forward wire boom system.
I don't think it actually penetrated the aluminum layer, but it did change the texture of it.
Right, but it's actually in surprisingly good shape.
Well, when there's a failure like this, very first thought that passes through a scientist's mind is how are we going to get it right? How are we going to do it again? Well, it must have been really sad for you to open this up, Steve, and looked at what happened to all your hard work.
Yeah, it is about 2 years of work, but actually, again, it looks pretty surprisingly good.
That process will involve reproposing to NASA, possibly this summer, to do the experiment again. And then NASA has to decide if they have the resources available to do that. And then, oh dear, the electric field cans got pretty badly beat up.
Yeah, these took the brunt of the impact.
Now that the Bush administration has decided on a manned mission to Mars, funding for auroral scientists like Kintner is in danger.
There's always been a tension at NASA between the science side and the manned spaceflight side. And that tension was actually realized at the very beginning of the space program, which Kennedy created. And he asked Congress to actually wall off the science and the manned spaceflight side so they wouldn't be competing against each other. Now that tension has reemerged, and NASA has to work its way through of how to do the best science, at the same time, how to do the best exploration. Well, it's always easier to do things a second time around. I wish we didn't have to do it in this case, but we've got to find a way to make it happen. Space weather is still a bit of a mystery. It's not nearly as well understood as weather is down here where you and I breathe. But if we're going to become a spacefaring nation, we have to understand space weather, just as the seafaring nations 3 centuries ago had to understand the weather that we have. The collaborations for understanding the Northern Lights is primarily for those countries in the polar regions. And what's really nice about being a scientist is these collaborations transcend national boundaries. And we all realize that by working together, we can accomplish far more than we can by working apart.
Stand by. Here's the other receiver.
I don't know if we're going to understand all this. I think there's hope that we can. I don't think we should spend all the world's resources trying to understand it, but we should spend a small amount of our resources to understand it. And if we do, that will help us understand the cosmos as a whole. This most recent failure is in many ways devastating, but it's a prospect of getting it right, of discovering something before anybody else ever knows it, and being the person who explains it.